Alright, hopefully you guys took a couple minutes, it was only 2 minutes long, and watched the SSA ambiguous video. If not, go ahead and stop this and go back and watch it. It's really going to help explain this first statement up here, a couple statements. So, if we are given two sides and an angle, so let me just draw this picture and then we'll back up. So here is a triangle. I'm going to put angle A right here because it was given that it's 127 degrees. Side A across from it is 63. B, angle B was not given, but side B was, so it's 42, so obviously there's angle C and side C. Alright, so if you look at this, you're given two sides, but the angle's not between it, so it's not an SAS, it's a side-side angle. Alright, so if you have this case, I'm always going to say be careful, because it's possible that you might end up with two triangles with this given information. It's also possible that it might not work and you'll have 0 triangles, or you'll just be able to solve for 1. So you could get 1, 2, or no triangles. Alright, let's start with the given information. So just like what we would have done before, I'm given A and A. So I'm going to do the sine of angle A is 127.63. The only other thing that was given was side B, so I'm going to have to do the sine of angle B over side B. Notice right away here that it's an angle that we're looking for. So if I go ahead and start cross multiplying, I've got 63 times the sine of angle B is equal to 42 times the sine of 127. When I divide by 63, go ahead and type all of the stuff on the right into your calculator. So I've got the sine of B. When you type that into your calculator, you get 0.5324 and then a bunch of other numbers. I'm just going to write a few of them because I don't want to write them all. Alright, remember, when you're looking for an angle, you have to do the arc sine, or the inverse of sine. So sine -1, that's what it would look like on your calculator. Hit the second button. And then hopefully you didn't clear that number off, the 0.5324, because then you can just use the up arrow and hit enter, and so after you have sine, the inverse sine or arc sine, you can just paste or copy this number after it. When you do that, you're going to find that angle B is equal to, and we'll round to the nearest tenth, 32.2 degrees. So go ahead and try that. Alright, I've got 32.2 degrees right there. Remember, to find the third angle, remember 3 angles are just, they add up to 180. So if you do 180 minus 127 minus 32.2, you will find that angle C is equal to 20.8. 20.8 degrees. And we're just going to round everything to the nearest tenth here. Alright, now the only thing that's missing is this side. So I'm going to start to solve. I'm going to go back to my given information. I'm going to say the sine of angle A over A, oops, I know A is 63, is equal to the sine of angle C, 20.8, over side C. Now, I want to back up and tell you, I just chose to use angle A and side A because it was given, so I know for sure that it's correct. You could have done sine of angle B over B equals sine of angle C over C. So it doesn't matter which pair of sides and angles you use. Alright, when I cross multiply this, it's going to be just like the last examples were. So C times sine 127 equals 63 sine 20.8. Divide both sides to get C is equal to 28.0124, so just 28.0. Alright, so there's the answers for one triangle. It worked out great. Now, I want you to back up and look right here. If you look, remember what we did back in section 9.3? Sine, it's telling me that sine is a positive 0.5. So, that means that my sine value, which is my y value, is positive. So that means that what we just did has an angle or triangle here, that angle or triangle that's in the first quadrant. Now here's the thing, it is possible, because all they told us is that sine is positive, it is possible that we could have had the angle all the way over in the second quadrant. So it could have been all the way over here. I know for a fact that it wouldn't have been in the third or the fourth. So let's just look at a triangle in the third and the fourth quadrant, because these sine values would have been negative. So I know I don't want those. But it could have been in the second quadrant. Remember how we find the reference angles in the second quadrant? We do 180 minus whatever the angle was. Well, if you look, we knew that the angle, when we did the work, was 32.2. So if I do 180 minus 32.2, I'm going to get 147.8. So that's another possible angle. So let's see. Get rid of this stuff here. So I could have had a triangle. Let's see. Let me just go back, start all over. Angle A, it was given, it was 127. Angle B, don't know. Side A was 63. This is 42. And I'm looking for C. So I just did the work that told me my new angle B now is 147.8. So let's put that in the triangle and think about this for a second. What would we do to find angle C? Well, we would say that three angles add up to 180. All right, so let's just go ahead and do that. Let's add 147.8 plus 127, and right now I'm already at 274.8. So if I subtracted that from 180, I'm going to find that angle C, the measure of angle C, is negative 94.8. That is not possible. So I know that in this case, there is only one triangle that's going to work. This other one didn't work. It wasn't possible. Now, it could happen that you would have gotten a number for B or an angle for B that does work, and then we would go from there and find all the other missing parts. All right, let's look at another one. I'm always going to start by drawing my triangle and labeling what's given. So, it really doesn't matter where you put these. Put angle A, B, C. We'll just go like that. So angle A is 51 degrees. Side A is 3.5. Side B is 5. All right. So if you look at what's given, you're given an angle and two sides. The sides are, the angle's not between the two sides, so this is an SSA. Again, whenever you have that, be careful. All right. So given, we have angle A, so I'm going to do the sine of angle A, which is 51, over side A, which is 3.5, equals, I'm going to do sine of angle B again because I was given side B. Cross multiply, and we get 3.5 sine B equals 5 times the sine of 51. Divide both sides by 3.5, and we get the sine of B, of angle B. This time it's going to be equal to 1.11021. All right, if you do the arc sine and copy that number in, or whatever was after it, you're going to get domain error, which right away tells me that this is not going to work. There's no triangle. So there's no possible triangle with the given information. All right, so let's think about that. Why did it not work? If we go through and we look at a triangle where, here's our angle. Think about what sine means. Sine means opposite over hypotenuse. Well, the only way you're going to get a number that's bigger than 1 is if the opposite side is the biggest side and it's smaller than the hypotenuse. Is it possible for one of the legs to be bigger than the hypotenuse? No. So that's why there's a domain error. It's a nice easy problem because now you're done. All right, you've got a little bit of room on your notes, so let's go ahead and try one more example. All right, so go ahead and copy this down. If you don't think you're going to have enough room to write, go ahead and grab another piece of paper. All right, so again, I'm just going to make my triangle. And it was given that angle B is, and again, we don't care where we put this, I'll just put B here. B is 62 degrees. I don't know angle A, I don't know angle C. I know side B is 9, and side C is 10. So if you look, I'm giving you two sides and an angle that's not between it. So I'm giving you two sides, the angle is not between. Remember, you need to be careful with these. Let's start this. I've got the sine of angle B over B is equal to, we're going to have to do the sine of angle C here because I gave you side C. All right, if you cross multiply, all right, so if you cross multiply, you get that, divide both sides by 9, you're going to get that the sine of C is 0.9811. So if you do the arc sine or the inverse of sine, this time it's going to work because that's smaller than 1, we're good. You're going to get that angle C is equal to 78.8 degrees. So there's angle C, 78.8. If you put it in the picture, you can really see how it would be easy to find angle A. 3 angles add up to 180. So you do 62 and 78.8, subtract that from 180, and then you're going to find that angle A is equal to 39.2 degrees. 3 angles add up to 180. Doing good so far. Let's go on now and find, let me label the picture. Let's find side A. So I'm going to go back and use sine 62 over 9 is equal to the sine of A. I just found that, and that's 39.2 over side A. Again, let's cross multiply. All right, we're solving for A, which means we have to divide by sine 62 and type it into your calculator, and you're going to find that side A is equal to 6.4. All right, we're done. Almost. Remember here, we found that sine of the angle was positive 0.98. So again, if we're looking at our quadrants here, sine is positive not only in the first quadrant but also in the second quadrant because it's the y value. All right, so that means that I could also look at the angle that goes all the way across into the second quadrant. I'm going to figure that out by doing 180 minus whatever I found, which was 78.8. So another option for angle C is 101.2 degrees. All right, let's go ahead and make a second triangle just to see what's going on. All right, so there is the given information. I just found that C is 101.2. I know I didn't do a good job. That's not the obtuse angle, but it's okay. To find angle A, 3 angles add up to 180. So I'm going to find that angle A is equal to 16.8 degrees. So far I've got okay numbers. So it's looking like we're going to have two triangles. I still need to find side A, so I'm going to set up another law of sine. Sine of B over B is equal to the sine of A. We just found that is 16.8 over A. Cross multiply. And, you know, if you don't have to write all this, that's fine. I'm just trying to show all this for the notes. All right, kind of messy, but side A this time is 2.9. So it was actually possible to find two triangles. So now you've seen an example of one triangle, no triangles, and two triangles. All right, go ahead and give it a try. And I will see you guys in class. Make sure you do give it a try though. Please, 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 please.